All right, so on your unknown, this is what you're going to get. You're going to get a test tube. And if it were me, I'd make these notes either on paper or on your handout. The handout probably would be the best thing. The lab handout. You're going to get a test tube like this. And on that test tube, there's going to be a number. There'll be a 5-digit number. And everybody will get a test tube. And I talked about this yesterday in that there's easy unknowns and there are hard unknowns. The luck of the draw will be for you. You'll also get a dropper, which will be used only for your unknown. So you get a dropper, a test tube, and you'll get a card. All three of those are unique to you. The card looks like this. It'll have a place for your number. It'll have a place for your name. This is your lifeline, the card. All right? You will have an opportunity to guess at your unknown, not guess, but to submit your best conclusion 3 times. Now, what's in the test tube? There's a cation, which is positive, and there's an anion, which is negative. If you look at your handout, look at the possible cations. Right now, look at the possible cations. How many are there? 14? All right, so there's 14 possible cations. Look at the possible anions. There should be how many? 10. You will have one of those cations in your unknown test tube. You'll have one of those anions in the test tube. It could be any combination of them. So nobody in the room will have the same unknown. And it's your job at the end of the lab on Friday to tell me via the card what your unknown is. Okay? On the back of the card, you'll write your 3 reasons why you think it's the cation, your 3 reasons why you think it's the anion. I will look at those. I will look at this. I will look at the number. And I will tell you one of 3 things. It'll be incorrect. And this should be a 10 now. If I say incorrect, that means that neither one is correct. If I tell you half correct, minus 10, that means one of them is incorrect. One of them is correct, but I don't tell you which one. If I tell you correct and put my initials with the date, you're done. It's that simple. You can turn in the card to be checked with the 3 things on the back for the cation and 3 for the anion. You can turn in the card the first 5 minutes of the period, and you will get it back the same day. You can turn it in the last 5 minutes of the period. You'll get it back the next day. Usually what I do is I put my initials and the grade on them, and I put them in those trays where I return your papers. Let's say you turn yours in the last 5 minutes of this period. It'll be in there probably by third period. You can come by and get it and look at it. Okay? That's the deal with the card, and that tells you what you're going to get in there. Now, if you look at your handout, there are separate tests for the cation. Things you can do to determine your cation. And there are separate tests for the anion. They are totally independent of each other. One does not depend on the other. Just because you think your cation is sodium and it has a +1 charge does not mean that it has to be with something that's -1. It doesn't have to be that way. It can be any other charges. Okay? And you can't guess on half. You have to have the whole thing filled in. In other words, once you think you've got your cation, you can't turn your card in just to see if your cation's right. Then you go on and try your anion. When you think you have them both, then you can turn it in. And I will check it the first 5 minutes and the last 5 minutes of the period. All right? Part of the success in the lab is you want to write down everything you do. For instance, let's say, and this is your pre-lab, let's say I put today's date, all right, 4/28, test performed, flame test, results, yellow color. Which flames are yellow? How would you know? We did a flame test lab, and it's in your lab notebook. You go back and look at it and refer to it. Now you see the importance of keeping all your labs. You look up on Google. I've got a chart back there where the flame test is going to be done. Those are all set up back there in the back of the room already. It's set up almost already with the colors of the flames. And let's say you think, okay, it has a yellow flame, ions possible, sodium or barium. You write it down. Please write down every test you do by every day, because then you don't have to go back and repeat the same test. There's two problems with repeating the same test. One, the major one, is it confuses you. And two, it wastes chemical. You've got the result, write it down. More than likely you're right as far as the results go. You may not be quite right for the ions possible, but you might be correct there. Okay? So let's say you do a flame test for the cation. It tells you on the paper, or you have a lab in your lab notebook that tells you how to do a flame test. There's going to be a certain section of the room set up where you do the flame test. You only do it there. You don't do it at your work table. Your table where you are in the room is more or less just that's your house, that's your room. You keep everything there. But you're going to wind up going on all different parts of the room to do the individual test over there. There is one test that you're going to do at your table, and that's the precipitation test. And I probably won't get to that until Monday, and that's very important that you get the precipitation test down for that. All right, so let's take a look at our handout for the lab. Your possible cations are these: silver, potassium, mercury 1. Now, I know that looks like a 2, but there are 2 mercuries there at +2, so that's mercury 1. Aluminum, lithium, barium, sodium, calcium, ammonium, copper, iron, copper 2, iron 3, nickel 2, lead 2, and strontium. So your unknown cation will be one of those. Okay? Now I'm going to give you a very important piece of information right now. Sodium ammonium and potassium do not react in the precipitation test. Very important piece of information. Potassium, sodium, and ammonium do not react in the precipitation test. And nitrate does not react in the precipitation test. So if you get an unknown and you're testing the cation and you get no reaction in the precipitation test, what have you just done? You've divided it up into 3 people, 3 choices. That gives 1 color flame. That gives 1 color flame. That gives no flame. You get no flame, now what do you have? 2 choices. Okay, you see what I'm doing with this? This is the way you go about it. You have to go about it very systematically. That's why it's very important that you write down everything you do on your daily log. Okay? Now, as far as the rules of the lab go, these are things that can happen. Everybody in here will have a cleanup duty. I have to give you a cleanup duty because in order to maintain all of that, it has to be right for the next period. Okay? You'll know that before you go in the lab on Tuesday, what it is. At the end of the period, 5 minutes or so before the bell rings, I will say, clean up. The very first thing you do is secure your unknown. We put them away. All the period 1 unknowns will be put in the back, locked up. I'll put period 4 out before you leave. I have AP on 2nd and 3rd. So you want to secure your unknown first. Then you go to your cleanup duty. Make sure it's just like it was when the period started. You're fine. If the bell rings and I go back there and you're in charge of the nitrate test and the nitrate test has not been cleaned up, when you come to class the next day, I'll ask for your card and I'll subtract 20 points off your card. We have to stay clean. I already talked to you about half correct answers. What if you lose that card? I told you it's your lifetime. Depending on the longevity of the lab and where we are, it'll be between 25 and 50 points for a new card. Yes?
Are we allowed to hole punch the card so we can keep it in our mind?
That's fine. Okay? So you want to make sure you keep a hold of that card. All right. If you lose this lab handout and don't have one, don't bring it with you, I'll be glad to give you another one for 25 points. If you lose your dropper, which really is for you, they're sterile when you get them and nobody's unknown but yours should be put in that dropper. I'll give you a new dropper for 10 points. This has actually happened. Very first day of the lab. I give out the unknowns. People head to the lab. I usually divide the class in half. I'll say, this half of the room, you start with your cation. This half of the room, you start doing your anion first. So you go in the room and you're working. A person takes their unknown, instead of setting it nicely in the test tube rack, they set it up against the gas vent. The person from across reaches over to turn something, the unknown falls on the table, breaks. Your unknown is on the table. Now, you either have to be very good with your dropper and slurp it all up, or you get a new unknown. I'll be glad to give you an unknown, 50 points off. And the unknown will be different. Now, where this comes into play is you've got enough unknown in that test tube to do 2 of every test in there, if you are conservative. If you're not conservative with your unknown and you're just squirting it everywhere, you're going to run out of unknown. And you're going to come up to me and go, can I get some more unknown? Of course you can get some more unknown. Let me see your card. I'll go in the back and I'll get another unknown for you.
What if it's like a last name and you almost know what it is, but you ran out?
Then you better be good at making sure you wrote everything down so you don't need any unknown. Right? That's another reason why it's very important to write everything down. So be very careful with your unknown. Okay? The other thing that I do, and this is, it's by design. I don't want anybody to think that I hate you, that I'm not going to react to you, but I'm not going to answer any questions about the lab. Now, I'll show you what I actually have to do. Some of you will appreciate this. A long time ago, I was a soccer referee. So I carry with me yellow card, red card. If you come up and ask me a question, what does it mean when it doesn't precipitate with carbonate? I probably won't answer you, and I'll just go about doing what I'm doing. You follow me. Mr. Newton, what does it mean when it doesn't react with carbonate? Yellow card. If you get a yellow card, I put your name over there on the board, and from that point until exact same time the next day, you're suspended from the lab. So it's a 24-hour break from the lab. Of course, if you get 2 yellows, you get thrown out of the lab. And that just costs you 300 points. Done. All right? So, again, it's not because I dislike you. It's not because I want to be tough on you. But this is a rite of passage right now. This is the culmination of your chemistry. in this class. And you'll remember the unknown lab. Like I told you before, 85% of you will be successful. If you, for some reason, aren't successful and it gets to the wee hours of Friday and the bell's going to ring and you haven't gotten your unknown, that's okay. We'll make arrangements. I'm going to start Redox Chapter 19 that Monday. But I'll still have the lab set up. You'll just have to do double duty. You'll be in the lab working, but I'll be teaching Redox. That's the very last chapter we have, and it only takes me about 3 days to do it, and we'll be done. All right? So, the thing here is, you have to keep a cool head and not panic. But at the same time, you've got to be very methodical and write down everything that you do. And as I told you, there's some that are difficult. There's some that are blatantly easy once you get a feel for everything that we're doing. Okay? Now, what I want to do to help you figure out your unknown is I want you to look at the solubility table, which is this table in the lab handout. And I want you to write over here in other words, these are the cations right here. See them? Your cation is in there. But there are more cations there than are possible. Right? For example, antimony is not a possibility. So what I want you to do is I want you to take this list here of possible cations, silver, potassium, and mercury 1. Do this. Take one color highlighter and go and highlight all the cations. Silver, potassium, mercury 1, nickel, sodium, strontium, do all of them. Let's see, mercury 2, no, lithium, yes. Lead 2, yes. There's only mercury 1. Iron 3, not iron 2. Copper 2. No cobalt, no chromium. Calcium. No bismuth, no cadmium. Barium. No arsenic, no antimony. Aluminum. And ammonium. That should be the 14 cations. Now, here's the trick. Your unknown is going to be one of those. Your cation is going to be one of those, right? Your cation is going to be one of those. Now we have to go through and figure out which anions are possible. Okay? So the anions possible are bromine, iodine, and chlorine, and so forth. Those 10. So I'm going to take a different color highlighter and highlight those. Is PO4 possible on there, Anna?
Yeah, feel forward. Yeah.
I should have known that. Those are the 10 possible anions. Now, the very helpful part of this is all junctions with S are unknowns. That's probably the single most useful thing I could tell you about the lab. All junctions of those. Okay? So, can your unknown be calcium carbonate? Look at that. Can your unknown be calcium carbonate? No. So you know not to guess it. Why is I say no? Calcium's a possibility. Carbonate's a possibility, but calcium and carbonate are insoluble. That means they would be a solid in the test tube, not a liquid, and yours is a liquid. Can your unknown be copper 2 bromide? Yes, it can. Why is it? Copper is a possible, bromine's a possible, and it's an S. Can your unknown be magnesium chlorate? Can your unknown be magnesium chlorate? No, magnesium's not a possible cation, chlorate's not a possible anion. So you see why this chart's important. This is the single most important chart and information on the unknown lab for right now.
It's only going to be soluble, not slightly soluble.
It's going to be only soluble.
Alright.
So would it be advisable to turn in a card with lead chromate? No, you wouldn't want to do that because it's not soluble in water, and your unknown is soluble in water. So your unknown is soluble in water. Okay? Your unknown is soluble in water. Good deal. Hopefully there's some we can use, but there's some you can use.
Yeah, I can use all next door.
Any questions so far? Yes, sir.
We'll be getting our unknown Monday.
You'll either be getting your unknown late Monday or first thing Tuesday. I've got a lot of work to do yet because I have to pour 200 and some unknowns. Because I got to pour Ryer's, I got to pour his, and I got to pour mine. Because I'm the one that's basically in charge of the whole lab. All right. Any questions?
Don't some classes already have it?
No. Mm-mm. Yes.
Are you gonna have like the same amount with the test tube?
Yes. There's the same amount in each test tube.
How many do you use?
It holds about, I think a 13 millimeter test tube holds about 10 milliliters. All right, on Monday, what we'll do is I'll go back over this and I will run a sample unknown for you so you have an idea of what it is we're doing. All right? Any other questions? Now, make sure that you have this chart done. If it were me, my main objective for you before you come to class on Monday is read over this whole lab write-up. Read over the whole thing. Don't fail to do that because there are some very important information in there, especially here where it tells you how to perform the anion and cation precipitation test. Tells you exactly how to do that. All right? Okay. We're almost there.